So question 11 says that given that y is inversely proportional to x and that y is equal to 4 when x is equal to 3, find an expression for y in terms of x. So the key word there is inversely proportional. If I highlight that so you can see it, inversely proportional to, and the sign for inverse proportion is that one. So I would say that y is inversely proportional to x, and I can rewrite that as y is equal to k over x. Okay, we have that y is equal to 4 is equal to and x is equal to 3. So let's substitute in. We get 4 is equal to k over 3, and if we cross multiply, that's going to give us k is equal to 4 times 3 is 12. Okay, so if we have that, then we can then write I think that's perfect the way it is now. Yeah, 4 is equal to k over 3 and k is equal to 12. That's perfect now. You can always find x given y, or you can always find y given x. So that's done. 11b is a substitution problem. So now that we have 4 is equal to k over 3, we could use that expression. We know what k is. We can use that expression to find the missing numbers. The one that is missing here is in the first empty box is y. We're given that x is equal to 0.25, and we want to find y 0.25. If I rewrite it, that would be 1 over 4. Yeah, so y is equal to 12 divided by 1 over 4. Yeah, if we work this out, we're going to end up with y is equal to 12 times 4, and that's going to give us 48. Yeah. If you want me to explain that a bit more, then 12 divided by 1 over 4 is equal to 12 times 4 over 1, which is equal to 48. Okay, so this would be 48. And in this other one, you have y and you're looking for x. So 1/5 is equal to 12 over x. And x would then be equal to, if you cross multiply, 5 times 12, which is equal to 60. So in this box, I'm going to have 60. So that's that question answered. Okay, so question 12 says express this fraction here as a single fraction in its simplest form. So with fractions, adding or subtracting fractions, what we're aiming for is a common denominator. So let's start by writing a common denominator. If I say that is 3x plus 2 times 2x plus 7. Sorry. Then 3x can go in. This can go into 3x plus 2, and we would have 3x times 2x plus 7 minus this can go into 2x into 2x plus 7, and we will have 2x times 3x plus 2. Okay, if we expand that, we're going to have 6x plus 21x, 6x plus 21x minus 6x minus 4x. 6x is going to cancel minus 6x, and there we would have 3x plus 2 times 2x plus 7. And if this cancel this, what will be left with will be 21x minus 4x. So if we write that down as 21x minus 4x would be 17x. That would be 17x over 3x plus 2, 2x plus 7. I think that question has been answered.
Now, question 13 says the points P, Q, R lie on the circumference of a circle with center O. PQ is the diameter of the circle. The straight line ARB is a tangent to the circle. QRB is equal to X, where X is measured in degrees. And the question says, calculate the size of PQR in terms of X. You must give a reason for each step of your solution. When I look at this now, this here is almost like I think this is the alternate segment theorem, yeah, where this angle is equal to the angle in the alternate segment. So this would be equal to X, definitely equal to X. And I'm going to write an angle. Where should I put that now? I think I should put it in the answer area. Angle R P Q equals X, and I'm just going to write my reason. Alternate segments. And this angle right here is equal to 90 degrees. Yes, so angle PRQ is equal to 90 degrees. Angle in a semicircle equals 90 degrees. Angle in a semicircle. So those are my reasons, and you have to state your reason. If you don't state your reason, then, well, you won't get the marks. Therefore, now the angle that I'm looking for is angle PQR. So PQR is inside this triangle, and I've already got those two angles. So I just need to use angles in the triangle. So angle PQR, let's put the little carrots on top of it, is equal to angles in a triangle equals 180 degrees, so that would be 180 minus 90 degrees minus X. This would be equal to 90 minus X, and that would be the final answer. I'm just going to write my reason for this one. Angles in a triangle. Okay? And that's it. That's done. Okay, question 14 says Aled has 3 concrete slabs. 2 of the slabs are square with each side of length x centimeter. The third slab is rectangular and measures 1 meter by x plus 1 meter. The 3 concrete slabs cover an area of 7 meters square. Show that 2x squared plus x minus 6 is equal to 0. Okay, let's make a little sketch of this so that you can understand what's going on here. So this is one of the square ones, it's another square one, and this is the rectangular one. You have x here, which gives you x squared. You have x here, which gives you x squared, and you have x plus 1 and 1. Yeah, so this is going to give you x squared. The first square will give you x squared, plus the second square is x squared, plus the third square is going to be x plus 1. Okay, and they told us that that is equal to 7 meters square. Okay, if we collect like terms here, we would have 2x squared plus x plus 1 is equal to 7. And if we take 7 to the other side of the equation, we would have 2x squared plus x minus 6, because plus 1 minus 7 is equal to minus 6 is equal to 0. So that's done. Yeah. And now question B is asking us to solve the equation to find the length of each side. So you can do this using any method of your choice, but I'm just going to use factorizing. If we write this down as 2x squared plus x minus 6 is equal to 0. If we're using factorizing by decomposition,
Then we want to find AC to start off with. AC is equal to minus 12. And we're looking for the factors of minus 12 such that they can give us the coefficient of this x here in the middle. So we can try, I think I did try a couple of them and I got 4 times minus 3. Plus 4 and times minus 3 would give you minus 12, and plus 4 minus 3 would give you x1. So let's replace this x here with plus 4x and minus 3x. We would have 2x squared plus 4x minus 3x minus 6 is equal to 0. Let me start with this side of the equation, and then I'll try to make this other side. If I factorize this one, and I split it into 2, factorize this and then factorize this, this is going to be 2x x plus 2 minus 3x minus 3, it's x plus 2 is equal to 0. 2x minus 3, I'm going to grab this one and this one, which is outside the brackets, and then I'm going to take one of the brackets that are the same. One of these two brackets is enough, and that will be equal to 0. And now that you got the two brackets that are being factorized, we can say either 2x minus 3 is equal to 0 or x plus 2 is equal to 0, in which case 2x is equal to 3 and x is equal to 3 over 2. Or 1.5, yeah? I'll put that as equal to, and then here x is equal to minus 2. Okay, so the area should be x is equal to 1.5 there, x is equal to minus 2. Depends on what the examiners are looking for. They probably ignore one of the answers, yeah? So make sure that you solve it all the way down and get your solution. Okay, question 15 says the diagram shows a sketch of the graph y is equal to f of x. And the graph passes through the points minus 1 and 0, 5 and 0, and the highest point is 2 and 7. And it wants us to sketch, okay, it wants us to sketch y is equal to f of x minus 3 on the same on this axis, yeah? And we must include the coordinates of the points of intersection of the graph with the x-axis and the coordinates of the highest or the lowest points. So let's start off then. F of x minus 3 is going to slide the graph to the right. Yeah, it's going to slide it to the right. So, and if it slides it to the right 3 places, then this point here, 5 and 0, will become 8 and 0. 8 and 0. And this point here, which was minus 1 and 0, it becomes 0, 1, 2. It'll become 2 and 0. So I got those 2 points where it's crossing the x-axis. Yeah. Now, at the highest point will still be y is equal to 7. Y is equal to 7, but it's going to be in between 2 and 8. I'm sure that is 5. In between 2 and 8, that should be 5. So that this here should be 5 and 7. So once we got those 3 points, we can then join them all up. It's a sketch, so nobody expects it to be perfect, yeah? Nobody expects it to be perfect. Just sketch, make a little sketch showing, indicating the coordinates of the point of intersection of the graph and the x-axis. So those 2 points and the highest points. Yeah? Okay, that's it. Now question 15b says, using this axis below here, sketch the graph of y is equal to cosine x plus 1 for values of x from 0 to 360 degrees. So let's make our little markings of 0 to 360 degrees to start off with. So if this is 90 here, this is 180, and this is 270, and this would be 360. Remember, your cosine graph is the one that looks a bit like a bucket, something of that sort of shape. Yeah, but this one now is cos x plus 1. So instead of it, the normal cosine graph is going to come down here, going through 90,
and being at it will be at 1 here, yeah, 1 to minus 1, yeah, and it's going to come down all the way to 180, going back up, passing through to 270, and stopping at 360 there, right there, yeah. But this time it's cosine x plus 1, so we're going to have it on 2 this time, and because it's going from 1 to minus 1 before, it's going to now go from 2 to 0, so you're going to start from 2, still going through 90, yeah, but this time touching 180, okay, the lowest point, and then going back up and finishing off at 360. Yeah, so this would be you can label it y is equal to cosine x plus 1. Okay, you label this one so that your examiner knows that you know the one that you're talking about. Okay, question 16 says that triangle ABC is an isosceles triangle with angle ABC equal to angle ACB. P and Q are points on AB and AC respectively, such that AP is equal to AQ. Prove that triangle ABQ is congruent to triangle ACP. You must give reasons for each step of your proof. So looking at this now, I'm going to, because there are several, I think there are 4 ways that you can prove that 2 triangles are congruent. And one of the ways that I can spot straight away from looking at this is a side. So let me just show you how you can prove that. AB is equal to AC. Angle line AB is equal to line BC. Isosceles triangle. That's my reason. Now AP is equal to AQ. That was given. Yeah. So if I make a little sketch of those two triangles that you're trying to prove congruence for, yeah, I think one of them is like this and the other one is like this one. The other one is this one, coming all the way down, and this is A, B, Q, and this is A, P, C. Okay, we've already proved that AB is equal to BC is equal to AC. Sorry about that. Should be AC. AB is equal to AC, so that's one side proven, and AP is equal to AQ. That's given in the problem. If AP is equal to AQ, then that means BQ must be equal to CP. BQ must be equal to CP. Yeah, and they're given, and therefore BQ is equal to CP. Hence, you can begin to make your concluding statements. Hence, triangle ABQ and ACP are congruent, and you give your reason for them to be congruent. You say that the 3 sides are all equal. Side, okay, and that's SSS usually. Question 17 is a surd problem. It's asking you to simplify and then decide whether it is rational, whether the answer is rational or irrational. So I'm going to solve this problem in little chunks. I've got this 5 root 3 squared, and I think if we simplify 5 root 3 squared, let me move this up a little bit so that we can get a bit more space. 5 root 3 times 5 root 3.
Okay, we can multiply the whole numbers. 5 times 5 is going to give us 25, and root 3 times root 3 would give us 3, and that is equal to 75. So we got 75 here. Okay, and 2 over root 18, 2 root 18 divided by 2 root 18 divided by root 2. If we try and rationalize the denominator by timesing the top and bottom number by root 2, then we would have 4 root 2 times root 2 would give us root 2 times root 2 will give us 2. 2 times root 18 times root 2. If we multiply those two, we would have 2 root 36, and root 36 is equal to 6. Sorry. Root 36 is equal to 6, so that would be 2 times 6 over 2, which is equal to 12 over 2, which is equal to 6. So on this side, we have 6. 75 minus 6. And then on the bottom of that fraction there, we have root 32 times root 2 here. That's going to be root 32 times root 2. If I put the two roots together, that's equal to root 64, which is equal to 8. So I'm going to write that down as 8. Let's simplify this now. 75 minus 6 is 69 over 8, which is rational. Done. Okay, the last question in this exam is question 18, and it says a game played at a children's party involves throwing a ball into a bucket. Each child tries to get the ball into the bucket in the least number of throws. On each attempt, the probability that Sophia gets the ball into the bucket is 0.8. Each attempt is independent of any previous attempt. Show that she is 5 times more likely to get the ball into the bucket on her first attempt than to have her first successful throw on her second attempt. You must show all your workings. Okay, people do all this type of problems differently. When I see probability problems, I always think of a probability tree. So I always like to make a little sketch of my problem on a tree. So I'm going to draw my little tree on the side here. So getting a ball into the bucket is 0.8. Yeah. So not getting one in the bucket must be 0.2. And this is a win, and this is a lose. This is a win, and this is a lose. This is a win, this is a lose. Okay, and you still have on here 0.8 and 0.2 because they are all independent. It says 0.8 and 0.2. Okay, so show that she's 5 times more likely to get the ball into the bucket on her first attempt. Her first attempt is 0.8. Okay, first attempt. 8 over 10. Okay, then to have her first successful throw on her second attempt. So first successful throw on her second attempt would be this one here. Yeah, so losing and then winning. So that would be second attempt success would be 2 over 10 times 8 over 10, which is equal to 16 over 100. 16 over 100 is so let's have a look at those two items. If we have a look at 8 over 10 and I can simplify this to 4 over 25, yeah, and 4 over 25.
Right, how can I make the bottom numbers the same to be able to make that comparison? Because if I want to compare those two fractions to see how many times more the other one is than this one, then I need to maybe make the bottom numbers the same. So if I times this by, I want to make it 100 by 10 and times this by 5, then I'm going to have my new fractions will be 80 over 100, and this one would be no, this is times 4, yeah, 16 over 100. Okay, and 16 is 5 times, yeah, 16 times 5 gets you to 80. So that question has been answered. Okay, 80 is 5 times more than 16, yeah, so 16 times 5 gives you 80, therefore it's answered. Okay, I'm just going to write it to answer the question. 16 times 5 gives 80. Therefore, she is 5 times more likely to get the ball in on her first attempt. So you just make a concluding statement and you end it, and that's the end of this test. Congratulations. Bye now. See you in the next exam paper. Bye.